reference planes have direction. And this is a little bit of a challenging concept, unfortunately. In general, it's predictable which direction the reference plane is going to go in for the ones that you create yourself, because you're going to click and place the 2 points that define the reference plane. So if I start back here in Plan View and I go back to my Home tab, click on my reference plane tool, if I click my first point and drag to the right, I'm going to get one behavior. If I drag to the left, I'm going to get a different behavior. In other words, the first point to the second point determines the direction of that reference plane. If you imagined that there was a normal direction or a positive direction of that reference plane from the start point to the end point, that direction would, in this case, point up. So if you were standing at the start point, looking toward the end point, so imagine that I'm a person standing right here and looking this way, then the positive direction will be on your left. Okay? And if I name this reference plane, I'll call it B, click into the front view, go to my Home tab, click the Set button, I'm going to set that work plane active, and then draw another extrusion. Again, I'll just do a simple cylinder. Doesn't really matter what shape. You're going to see that that rule bears out that I just described to you. So again, imagine you were standing here on the left end point, looking toward the right point. The extrusion went to the left. Now, another interesting little behavior is that I can actually select this, and if I decided that the direction is not what I wanted, I can actually grab this little endpoint and start to basically reverse the direction by pulling it the other way. So you notice how is once I kind of reversed it on itself and what got past the other endpoint here, the form that's on that reference plane actually flipped. So the rule continues to bear out. Now I'm standing here looking toward this direction, and the extrusion is still going to the left. Okay, so again, just always imagine you're standing at the start point, looking toward the end point, and the extrusion will go to the left. You reverse it again, see how it flips around to the other side. Another way you can kind of look at this is the label tends to be at the second point. It tends to be at the end you're looking at. That's the part that's not terribly consistent, and I wish that it were. That's definitely a good reference material for you to look at. What Steve goes on to say at the end of that post is to talk about a little anomaly here that's somewhat disturbing, is that if we stood here and looked here and we follow the rule that says that the label is at the end, as we've seen with the ones that we drew, okay, there's the label at the end, here's the label at the end, positive direction, well, here's the label at the end. This should have extruded up rather than down, because if I'm standing here, looking here, my left, it would have been up in this case, and it didn't prove to be the case. So some of the family templates that ship with the software, the default built-in reference planes, don't really respect the rule. With all the testing I've been able to do, as best I can tell, is that's only really an issue with some of the built-in reference planes. So it's something I want you to be aware of, because as you get serious about creating forms here in the Family Editor, you have to be aware of this issue. The fact that I showed you here that you can actually reverse the reference plane is one way that you can correct that. To reverse one of the built-in ones, you'd have to actually unpin it and flip it around this way, and then you see it flips over, and then I could, sort of stretch it back, and then I could repin it. So it is possible to even reverse one of the built-in reference planes to kind of correct the problem, but it's something that I recommend that you do first before you build any serious geometry. You really don't want to be reversing the reference planes after you started creating geometry, because things will move in funny ways. Now you're at least seeing what we mean by a normal direction and a positive direction on reference planes. You know that that matters, and that helps you control where the positive extrusion or depth is going to be, because otherwise, without that, you'd have to actually make this a negative, which is another opportunity that you have. You can actually use a negative depth. So there are a few different ways to deal with the issue, but now you're at least aware of what the reference planes do and that behavior. And with that, we'll be able to move on to the next several movies here where we talk about each of the individual forms. So to illustrate some of the features of the extrusion, I'm going to create a brand new family, and this is going to be a throwaway family. I'm not actually going to save this at the end, so feel free to follow along in any file you like. I'm going to just use a generic model for this example. A generic model is sort of a non-category. It's good if you're really not sure what category you need, or if the category that you are thinking of doesn't really exist in Revit. So I'm going to tile the windows, zoom them all. I just did WT for window tile and ZA for zoom all. So we've discussed reference planes and work planes, and we know that the view that we're active in will help establish that. For this example, I'm going to just work in plan view. I don't really care so much about the work plane. I'll go to extrusion, and we're going to look at these different shapes here. So we've done rectangles already. Let me just switch to maybe something a little different. So I'll do a polygon. The default is 6 sides. I'll draw it right here at the center and maybe out to a 2-foot radius. What I've been doing up until now has been ignoring the depth parameter that is controlling how tall this extrusion is. And so you do have a few options. You can actually change the depth before you finish the form. Maybe I want this to be 4 feet tall, so I can plug in the number 4 here before I click finish. And you'll see that the height of this thing will be a little larger than what it has been previously. But of course, you can always change that depth later. The depth is also expressed here on the properties palette. So this is something we haven't really looked at too much before, and I'd like to kind of discuss this now. We have talked about the work plane in other movies. So in this case, we see that the work plane is on the reference level. The extrusion itself, the height of the extrusion, even though it's expressed as a depth right here, is actually 2 numbers. There's the extrusion start and the extrusion end. So if we direct our attention to one of the elevation views and I start fiddling with some of these numbers, you'll see how this behaves. Suppose I set the extrusion start to -2 feet and click apply. What will happen is if you look down in the front view or the left view at the bottom of my screen, you'll notice that this extrusion has just dropped below the ground plane. And if you look on the options bar, you see that the total depth is now 6 feet. So Revit kind of does the math for us. So I can start at any absolute point and I can end at any absolute point. And then the result is just the math being done between those two. So either of these can be a positive or a negative number. So this is one more thing to consider in addition to your work plane is both the positive and negative extrusions. In some of the future movies, we're also going to look at these little buttons over here. I just want to point them out right now, though, and say that this is a way that you can actually link up parameters to this extrusion and make these values parametric. You could put dimensions on the form, as we saw in the last chapter, but if I click this little button here, I have the ability to actually link up a parameter directly to that value. And again, that parameter would be a number, and it could be either positive or a negative number. If I have a reason to do that to drive and control the shape of this form, that's another option that I have available to me. So the way that you structure the work plane, the start point, the end point, all kind of factor into your overall strategy for how you want to build this form. But otherwise, pretty simple, straightforward form. If I create another one, of course, we have really any shape we like, but just remember, the shape must be closed. If you try to finish it before you close the form, you'll get this error message here. So I could click continue and say, oh yeah, I need to finish up my form. That gives me the extrusion. If I decide I want to cut a hole in this form, I can do edit extrusion and I can add another form inside of it. And then it will extrude as a hollow, basically. You can have as many closed loops as you want inside that extrusion. It's all in the single sketch. But what they can't do is overlap one another. If I took this circle and I did this and I try to finish it, Revit will complain about that too. As long as you make a valid sketch, really pretty much any shape that you like is acceptable. It's by far our simplest form. Extrusions are the simplest of our 5 forms. We need only the single sketch, as we've seen, to create them and an appropriate work plane. But despite their simplicity, extrusions are widely used in most families and really are the staple of form creation. So as with the previous movie, I simply have an empty family file on screen here. This was created with generic model, but you could follow along in really any template. All the forms work the same in any template file. The first thing that we want to do is decide what's the most logical view to build this thing in. Now, if I worked in plan view, then I'm going to be spinning around an axis that's going to be within the plan plane. Probably easier to just illustrate than to explain. So click on the revolve form, and you see that there are two buttons here, boundary line and axis line. And if you did the previous chapter, then you've already seen an example of this. We have all the same sketch tools that we had for extrusion, so these are pretty common tools. For this one, I'm going to do a simple rectangle, and I'm going to draw it just in plan over here. Then I'm going to switch over to my axis line, and you can either draw it or pick it. I'm going to draw it over here somewhere. Now, when I deselect this, what you're seeing is the axis is here, the sketch is over here. So in order to spin this shape around this axis, it's essentially going to orbit around that line, and you're going to get a donut shape or a ring when we're done. When I click finish, because we're working in plan and it's spun around this axis, it's actually spinning up towards and away from me. And when you look at it here in 3D, you see that I sort of have this ring shape that's been created vertically. Elevation is probably the easiest way to see this in the front elevation. So the shape that we drew was here, and it's spun all the way around the axis that was right there. Now, if you edit the form, you can edit either the shape or the axis line. So I could come in and change the shape, but I've got to make sure it's enclosed. If I tried to finish right now, I'm going to get an error. Just like we saw with extrusions, the revolves have to be closed shapes. So I'll make sure that I snap that over here, and I click finish, and we still end up with a donut shape here, but now it's got a little taper to it. As you can see, it's following that new form that I created. Let's edit it again. What would happen if I took the axis line and moved it a little closer? Well, now I get a much tighter circle. Naturally, if I edit it again and move it further away, I get a much bigger ring. And perhaps I change the angle, and you'll get a ring in another angle. So you can see, without changing work plane at all, or really doing anything to the overall form itself, just by changing the axis line sketch or the sketch of the shape itself, there's a wide variety of possibilities. So part of the challenge when breaking down the form you're creating is to break it down into these simpler forms, like to look at the object that you're trying to build in the family editor and think about which forms it should be constructed from and break it down into those smaller parts. So maybe you can use an extrude for a little piece over here and a revolve for some other piece over there. And then when you bring them together, you get the completed form. In the extrude, we looked at the properties palette. We saw that there were some properties. We saw there was work plane, as we have here, and I'm again using the reference level work plane. But now instead of a start and an end extrusion, I have a start angle and an end angle. So I can do some interesting things right here. What would happen if I changed the end angle to 180 degrees? Well, now instead of getting a full circle, I get a half ring. Put it in any angle I like and get smaller and smaller chunks. I can even put in negative and make it go the other way. The concept of work plane and the direction of the work plane that was discussed in the first movie in this chapter applies here as well. The direction that the angle is going to be measured from is going to be in that positive direction of the work plane. If you want to reverse that, you can use a negative angle. But you can do both a start angle and an end angle. If I change the start angle here to 20 and the end angle to negative 45, you see what starts to happen. It starts down here, and then it goes past and ends up over here. So the work plane is in the middle somewhere, but by changing the two angles, you can influence the way the overall form gets created. And then in a similar fashion to what we saw in extrusions, these forms can also use multiple shapes. Same rules apply as long as the shapes don't intersect one another. And now I've carved a hole in the middle of my form there. So that's our revolve form. A lot of similarities to the extrusion, but it rotates along an axis rather than extruding along a straight path. In this movie, we will look at the blend form. A blend is essentially an extrusion, but between two shapes rather than one. You sketch a base and a top, and then Revit blends between the two forms along the depths of the blend. Let's take a look. I'm in a generic model family template again, just a regular blank template. Again, you could really do this in any template you like. We've got a solid blend tool here on the Home tab. And like all the other forms we've seen so far, when you click on it, it takes you into sketch mode. So we've got all our normal shapes, and I'll keep this one relatively simple here. And I'll just draw a little rectangle down on the floor plane. In order to complete this form, notice the green checkbox isn't even available. So that's your little clue that you're not done yet. You have to do something else to this form. And the other thing that you have to do here is you have to switch to the top. So your blend is two sketches. We sketch the base and then we sketch the top, and then Revit will just sort of interpolate between the two. So let's go to Edit Top, and that puts us in another sketch mode, and the button changes to Edit Base. So you can sort of flip back and forth between the two. The base is currently grayed out, and I'm just going to do a little tapered pyramid sort of shape there. So I'm going to draw a second square. Probably the first thing that's a little confusing conceptually about the blend is notice that I've drawn both shapes in the same plane. So at first it sort of seems like that might not be right. Like, why would you do that? But notice there is a depth property here. It's kind of using that same methodology that the extrusion used. So that depth is going to get applied, and there will be a 1 foot difference between these two sketches. So let's go ahead and click finish, and we'll see what it does, and then we'll manipulate it a little. So we can sort of see the taper here in plan view, but it, of course, is a little easier to understand if we look at it in some of the other views, like 3D or elevation views. The 1 foot depth we can see right here. I'm just putting the dimension just so you can see that that's definitely the 1 foot there. I'm not going to do anything with that dimension rather than just have it there for information. So if I change the depth here to maybe 4 feet or something, notice that the shape of the sketches, the base and the top, doesn't change. What happens just is the height of this thing changes and the sides of the taper end up changing angle to accommodate. So we're still doing the same base and the same top, but we're ending up with a different taper on there. And of course, it says we're 4 feet here. So even though both sketches were drawn in the same work plane, the height gets applied. Now, some interesting things start to happen if you build the two sketches in different work planes. Let me show you an example of this. I'm going to do a reference plane, and I'm going to make it a little more rational here. So I'm going to make it 3 feet off the floor. I'm going to select it, and I'm just going to name this top. So it's got a name, and so now that can be a work plane. You've seen this in previous movies. There's two ways that you could use that top. You know, if I wanted to make the height of this blend parametric, the easiest thing to do would be to put a dimension between here and here, select this dimension, label it with a parameter, call this height, and then take this blend and stretch it down, snap it to that, and lock it. Notice I hadn't edited anything about the blend itself, its sketches, its work plane, but over here, if we look at the properties palette, the properties look very similar to our previous extrusion and revolves that we looked at. We've got our work plane listed, we've got our first end, we've got our second end, here's our depth, and you can see it's doing the math correctly. And now, of course, if I wanted to flex this parametrically, I can just move that reference plane, and because I previously locked it, it's going to lock and adjust. I think that's probably the best way to control a blend. Don't try to put the two sketches on two different work planes, but let's just say, for the sake of argument, could we put the two sketches on two different work planes? And the answer is yes, we could, but some interesting behaviors. The first thing I want to do is remove the parameter, because otherwise we'll get a constraints not satisfied error message if we try to proceed. Unlock that, and then let me just move this up a little bit. Okay, so we're kind of removing all the previous constraints that we just applied, and let's look at the alternative approach. So I'm going to select the blend in the plan view, and notice you get two buttons now, Edit Base and Edit Top. The base is already fine. The base is drawn on the ground plane, so we don't need to edit that. I'm going to jump right to Edit Top. And there's the sketch. Now I want you to watch it here in 3D and in elevation. I can do Set Work Plane. From the drop-down here, I can choose Reference Plane Top. I'm going to click OK. And notice the sketch has moved up, and there it is, it's moved up. Now that seems like the more logical way to do it, right? Because we now have one sketch that's down on one work plane and a second sketch up on the other work plane. Let me click Finish. But what in fact happens is it sort of does an additive situation here, because notice the second end is still the full depth of the blend. If I change this to a more rational number, what you see is full depth is now being measured from that secondary work plane, which gets a little confusing here. Now, so the real question is, could I make it so that it essentially snaps to this? Well, you can try. You can put 0 for the second end and apply it. You're usually going to get an error message. Did the blend is too thin? This is kind of funny because it says it can be ignored. It doesn't like it. And generally, if Revit complains about something, you should probably see the warning. It doesn't like it, but I can click OK and basically get that end result. And now if I took this and moved it, it does work. But personally, there was an error involved in this approach, and there wasn't an error involved in the previous approach with the parameters. So personally, it's my recommendation that you use the first approach, where you draw both sketches on the same work plane and use either parameters or the properties directly here on the properties palette to control the height, rather than trying to put the two sketches in two different work planes. In this movie, we'll look at a sweep. A sweep takes a sketch shape and moves it along a path. The path can be drawn directly on screen as a second sketch. So in some respects, it's a little bit more flexible than what we were able to do with either a blend or an extrusion, where the path was just a simple straight line controlled by a height. Here, we get to actually draw it any shape we like. So I'm going to do a couple examples. The first example, go to Sweep on the Home tab. I'm just going to draw everything. So the first thing that you see on the Sketch tab is two options for creating the path. You can either sketch a path or pick a path. And we're going to look at both, but we'll start with sketch. So I'll click that. And that introduces me to the familiar tools. Now here's the most important thing about the sweep that's a little different than the other shapes we've looked at so far. The path can be any shape you like. It does not have to be closed. So this is a perfectly valid path. Now press escape, and I've got this 3-segment open path. So if I were to click finish, it's not going to complain this time and tell me that I've got to enclose the shape. Now what I'm going to do is show you here in some of the other views what we're seeing. Go ahead and click modify here. There's this green dashed plane that appeared on the first segment that I drew. That plane is the sketch plane for the shape that's going to move along this path. Kind of keep that in mind when you're drawing your path, is that the first segment that you create determines where that plane goes. So if I go to the Sketch tab and I click the green checkbox, the mode I'm actually finishing is actually the path. So notice that that keeps me in the sweep, and I could return to the sketch if I wanted to. The path turned black to indicate that it's complete. And what I can do over here now is tell Revit how I want to create the profile or the shape that's going to move along the path. And I have a few options here, but the one I'm going to do is to do it by sketch and just simply edit the profile. So when I do, that will ask me what view I want to work in. It's important to make sure you're looking at this plane. So it's offering me a few views to choose from, like the left and the right view. Well, since we already have the left view open over here, I'll go ahead and choose that one and click Open View. Now, it is possible to work in the 3D view as well, but I think it's easier to sketch in these parallel views than it is to sketch in the 3D view. This red dot represents the insertion point of the profile. You could really draw directly on this insertion point, which is a pretty logical thing to do, or you could draw relative to it. It really depends on the shape you're trying to draw. But in this case, I'll just go ahead and do something. Okay, so it doesn't really matter what shape I'm drawing. This shape does need to be closed. So this is going to form solid geometry, so we're back to the same rules that we had with the blend and the extrusion, where it's got to be in closed shape. But it also could have internal shapes if you wanted to. So now I'm going to make like a hollow tube along that path. That's fine. But again, the same rules apply. When I click finish, I'm finishing that sketch. And you see that I'm still in the sweep command. So I could return to the path and change the shape of the path. I could return to the profile, change the shape of the profile, or I could finish it. So let's go ahead and click finish. And that extrudes along the path now. So that's another way to think of a sweep, is it's basically an extrusion along a custom path that you get to sketch. And if I spin this around, you can see it there. Now I did a 3 segment path, but I could have just as easily done a 1 or many segment path. It's really up to me. That's one of the advantages of the sweep. And sometimes folks will actually use the sweep to do things that they could otherwise do with an extrusion. And why would we want to do that? One of the advantages of the sweep is, let's just go ahead and create one real quick here. I'm going to do a sketch path, and I'm going to just do a single segment path. Finish that. One of the advantages is you can use a profile. And so sometimes folks will do that as a way of making the sweep more complex. Now for this example, I'm just going to stick with a shape that I'm going to sketch. And you can see that when I finish, it doesn't look much different than what I could create with an extrusion. So the two main differences are, if I would prefer to sketch the path and have grip points and be able to draw it graphically on screen rather than use properties on the palette, notice that there are no numbers over here now. You can't type in a depth like you could with an extrusion. That's one difference in the sweep, and the other is the different options that you have for the profile. We will do a swept profile example in a later movie, so for now I'm going to skip that one and just stick with the sketch. I have one last example I'd like to show you. When I started this file, I had this simple extrusion here in the file. This is just an extrusion default depth. It's 1 foot tall and it's just a hexagon shape. You can draw any shape you like. One of the nice features of the sweep is instead of sketching the path, you can actually do pick path. Now, when I do that, the default behavior is going to be to pick 3D edges. And so it might be easiest to do this right here in the 3D view. And what I can do is I can start to click on the edges of this 3D form. You don't have to be limited to just one plane. So I can actually find edges that go down along the sides and wrap around. You can do your path anywhere in 3D space. When I click finish, edit my sketch, and in this case, I'll keep it simple and just do a simple circle here, a little tube. Click finish again. Notice that I was able to draw that in 3D. And one more time. And now my shape is following along the edges of this 3D form. Even better, if you edit this 3D form and change its shape a little bit and click finish, notice that the sweep will continue to adhere to that form. So that can be a really powerful way to create a complex form in your family where one form drives the shape of the second form. So in this case, the extrusion is driving the shape of the sweep. So as you can see, the sweep offers us many unique features not available in the other 3D forms. And so this makes it a preferred choice of many family authors. So let's go to our fifth and final form, the swept blend. The swept blend is sort of a combination between the sweep and the blend, thus its name. We get 2 shapes, 2 sketches, one for the start and one for the end, and then they move along a sketched path. So it's more like a sweep because you get to sketch the path. I'm going to start here in a generic model family like the others, go to my Home tab, and click the Swept Blend tool. Like the sweep, we're introduced with a couple ways to create the sketch. We can either sketch the path or pick the path. And in this case, I'm going to do sketch path. One little challenge that we have with the swept blend is that the path has to be a single segment. So that's a little bit of a limitation, right? If I draw with a straight line, then that's it. It's just a straight path. It's basically a blend, which would make you kind of wonder what the usefulness of this would be. Well, let's undo that and look at one of the other shapes here. For example, a curve. Now, if I do that, we start to see that, okay, now we're getting a form that we wouldn't really be able to do with a normal blend because a normal blend would just go along a straight line. So you do get some flexibility. We'll do a few other examples in a moment. If we look over here in the 3D view, what we see is 2 of these green planes, where previously with the sweep we only saw 1. So we're actually going to have 2 shapes that we're going to sketch, and like the normal blend, it will transform from the one shape to the other along the path, which is curved in this case. If you look here on the sketch panel, we see that there are 2 profile buttons. We've got profile 1, profile 2, and they can both be by sketch or they can be by loaded profile. And as I mentioned in the sweep movie, we will be doing profile examples in a later chapter. So we're going to stick with sketches for now. So I'm going to choose edit profile for the first sketch. I'm going to keep these sketches fairly simple, which means I should be able to work relatively successfully here in the 3D view. But what you start to see if you look at each of the views is if my sketch was more complicated and required a little bit more precision, it would become rather difficult to work on it in any of the views that I have available to me. Down here, I'm skewed to the angle of the plane. Here, I'm skewed to the angle of the plane. The plan, obviously, is not a choice at all. 3D is okay, but it's not fantastic. Well, let me finish this and switch to the second profile. Okay, so I'm just going to click this button and do edit profile just to show you one alternative that we have here. If I click the modify tool, if I click this viewer button, it's called the work plane viewer, you'll get this secondary window here. I'm going to move it out of the way and make it a little larger so I can actually see what I'm doing. And now you can see that I'm looking right at that plane. If the angle of the plane is not conducive to giving you a proper sketch, then you can use this work plane viewer feature and it should make it a little easier. Let's do something a little different this time. I'll draw an oval. So we're going to transform from a circle to an oval along that curved path. So we've just got curves in every direction here. Now you can close the viewer whenever you're done with it. You can see the path here. I can click finish. So now I have my first sketch, my second sketch, and my path. And one more time, finish again. And there is my swept blend. Maybe it's a piece of ductwork or something. I'm not really even sure what that is. It's a horn. But there's that curved form. So that's the basic concept behind the swept blend. All right, so getting back to the issue of the path, somewhat limiting this notion that we can only have a single segment path. But if you're somewhat creative and I go to my swept blend, sketch my path, then you'll notice that you do have some other choices here, like my spline. And it might take a little bit of effort here to build this, but if you're a little creative with your choice of path, it actually is possible to create a much more complex path and get around the limitation, the multi-segment limitation, because technically this is a single object here, this spline object. So I'm going to click finish, and this is now my path. Come over here. And again, I could use the work plane viewer if I wanted to, but in this case, I'm just going to use some really simple forms. Click finish and finish again. And it is definitely possible to get some fairly complex forms, even working within the limitation that the swept blend imposes on us with the single segment path. You just have to be a little bit more creative about it. So that's our 5 overall shapes. Any of those can be solid forms or void forms. And so in the final movie in this chapter, we're going to look at all of the forms together, both solids and voids, and compose them all into a single unified design. Each of the 5 solid forms that we've explored so far in this chapter can also be created as voids. Void forms carve away from the solid forms to which they are joined. If you create a void form in the same physical location as a solid, Revit will automatically join the 2 forms for you. As an alternative, you can create the void freestanding and then move it into place and join it to the solids later. The choice is up to you. What I have on screen is a file that brings together a sample of all the forms we've been talking about so far. Some of this I'm going to leave as a practice exercise for you to explore further, and what I'm going to focus on is the void forms in this file. So I'm going to start here at the top of this wrought iron bracket with this form right here. This is a blend that just goes from a simple square shape at the bottom to a long thin square shape at the top. I'd really like to kind of round off that top edge. Now you wouldn't be able to achieve a form like that directly with any one of the other solid forms. So it really requires the combination of 2 forms. So in this case, we're going to start with the overall solid, and then we're going to carve away from it with a void. Now I've provided some lines here to get us started and to make it a little bit easier to create this form, but feel free to experiment on your own and create a different shape if you like. We create voids in much the same way that we create the solid forms. If we look here on the Home tab of the ribbon, we've got our 5 solid forms here and a void form tool next to it that lists out the same 5 forms. So you can create any one of the 5 shapes that we've previously explored as a void form. In this case, we'll just do a simple void extrusion. Now, like we did with other forms, we want to pay attention to our work plane. So if we look at the other views of this project, what we see here is there's a reference plane along the back edge of this bracket, center front back. And if we look at the back view, we're looking right at that reference plane. Now, if you want to be sure that Revit is choosing that correct reference plane, we can click the Set tool, as we've done in previous movies. We can open up the list, and we can choose the center front back reference plane. Now, this will be confirmed for us here in the 3D view. You'll see that we're now using the plane on the back of that steel bracket as our work plane. And I'm going to go ahead and click OK. And then we're going to zoom in a little bit on this top edge here and create an extruded void form here at the top. Now, if I go to void forms and I choose void extrusion, I could trace over these shapes, or I can just use the pick lines and actually pick them directly. So that's what I'm going to do. And what I'm mainly interested in is this curve right here. The shape of this stuff out here is not terribly important. It just needs to be big enough to cover over the part of the form we want to carve away. So in other words, it needs to be big enough to capture these little corners that we want to carve off. So if I do the form that I have sketched here, it's more than big enough to achieve that result. If I click Finish and create the form, we're going to see something a little strange here. Now, first of all, the depth of the form is defaulting in this file to 12, so it looks like it's doing something different than what we've seen previously. Well, if we go to the Manage tab and we look at units, I've just simply taken the units in this file and changed them to decimal inches. So it's still the default 1-foot depth that we were seeing in other files. It's just now expressed in inches. So you can feel free to change the units in any of your family files that you like. Secondly, if you recall from my discussion at the beginning of this chapter about work planes, that there's a positive and a negative direction of each work plane. So in this case, the extrusion is actually going in the wrong direction. Now, we have a few ways we can deal with that. We could, of course, reverse the work plane, but if you recall, I recommended that you not do that late in the design process. In other words, if I came over here and tried to reverse this work plane now, it would probably have a detrimental effect on some other geometry in the file. So that's really not a good choice. Instead, all I have to do is just deal with this one void that's going in the wrong direction. And I can do that here with the numbers, or I can just simply do it here with the grips. It's really up to you. It depends whether you want to have some more rational numbers here, or whether or not the more random numbers are acceptable to you. Either way, it's not terribly important, because what we're going to see is when the void is done, the void actually becomes invisible, and we see the result of the void interacting with the solid that it's joined to. So I like rational numbers, so I'm going to go ahead and change these to 2 and -2 and click Apply, and that will reduce the size of this overall void down, and you see that it does intersect now the 3D form. When I deselect it, it will immediately apply itself to the underlying form. I can come in here, select these model lines, and just simply delete them. They're no longer necessary, and you can see the end result. I have this nice little curve here at the top of the finial and a more finished looking result. So we have a similar condition down toward the bottom. So let me just pan this down into this location here. And here I already have a void form that was previously created. And this void form is created in exactly the same way as the one we had up above. The difference is this void's already here. And so when we come in and create the new solid form underneath it, it won't automatically apply itself. So we'll get to see that different workflow in that situation. Now what I want to build here is a swept blend. So I'm going to use this curve that I've provided in the file as the path, and then I'll create my 2 shapes to finish off this curve down at the bottom. I'm going to go to the Home tab, and I want to make sure that my work plane is set before I get started. So I'm going to go to Set. If I know the work plane that's passing through this bracket, I could use the center work plane. There's one here, center, left, right. But I want to show you another option here. There's actually this pick a line and use the work plane it was sketched in. Just point that out to you as an alternative option that you can use in your own work. So since I have a line right there, I can click on that, and you'll see there is a work plane right there. 6 of one, half dozen of the other in this case. So I've got that work plane. I'm going to choose my swept blend, and I'm going to sketch my path. I'm going to choose the pick lines option, and I'll click on this curve that we've created. And that gives me my path, so I'll finish that. And here what I'm going to do is something that I alluded to in the swept blend movie and in the sweep movie. We're going to do it sort of in pieces and parts throughout the training series. So I've already provided some profile families here in this file. We mentioned in those previous movies that you can create a swept blend or a sweep using profile families instead of sketches. So it defaults to by sketch. But if you open up this list, you see there's actually some items here on the list. These are nested profile families. Now, in a future chapter, we're going to actually create the profile families ourselves from scratch. So we will learn how to do that. Here, to focus more on the void forms, I've just provided the profile families for us to use. So we can just choose them off the list. So for our profile one, I have this one called bracket finial profile one. And if we just take a quick look at that, it's just a pre-drawn shape. It's a 2D shape. The insertion point was planned carefully so that it ended up right on the curve, and it has this subtle little concave curve here to give a little bit more interesting finish to our form. I'm going to go to Select Profile 2, open up the list, choose my Profile 2, and that one's just a simple rectangle so that it matches up with the existing form. So it'll look like it's smoothly going from the arc curve into the swept blend. So I've got my two shapes. It's going to blend from this one to this one. I'm going to finish that. And if we spin around, you can kind of see the result. And now by itself, that's an interesting form, and we could leave it like that. But using the void, you can kind of see the way they intersect. We can actually cut off those hard edge corners there and make it a little smoother, a little bit less sharp edge, maybe a little more interesting. So we can use the void to do that. Because the void already exists, it doesn't automatically apply. So what we do is we use the cut geometry tool for this purpose. This just simply allows us to come in and apply the void to the form after the fact. So we click cut geometry, we select the geometry that we want to cut, and then we select the void. And when you do, the void will disappear and the effect will get applied to that form. So if I escape out of that command, notice that there's the swept blend. And if you move your mouse around here somewhere, there's the void form. So you can always get back to the original forms, select them, and edit them in any way necessary. But when they're deselected, you get the final result. So we're going to leave this file at this stage, and I'm going to leave these shapes over here for you to further experiment with this. Over here, you can add a sweep to finish off this end of the bracket. Here's the path of the sweep, and you can sketch the shape. And then if you look at these little collars over here, these are just revolves. And I've given you the starting point of one of those collars right here. Here's the form, and there's a path buried in there somewhere. There it is right there that you can use as the axis. So feel free to practice with this file and using these forms. Feel free to modify any of the forms that I've provided here and practice any of the forms that we've looked at in the previous movies and even add some more voids if you like. So while the focus of this movie has been on the void forms, the larger purpose of the file that we're working in here is to give you an opportunity to experiment with all the forms that we've been discussing throughout this chapter. So I do encourage you to spend some time and practice in here each of the features that we've looked at over the last several movies.